data communication. That is how two different devices with different hardwares, they can be connected so that they can share their information, they can be used for distributed computing, or they can communicate with each other. So this is the main motto of data communication. And what are the different components in this data communication? The main components are: there must be one sender who will send the data, there must be one receiver who will receive the data, there must be some information or message that will be shared, and there must be one media through which I have to transmit the data. So these are the different components, and finally, the most important thing, you have to follow some rules, which is called protocol. So these are the different components of any data communication system. So whenever we are going to uh, connect two devices, you have to take care about these things. And there comes how they will be connected in configuration, whether it is point-to-point, direct, or dedicated link between two devices, such as this one. In this example, these two devices, sender and receiver, are directly connected, or you can say this is a dedicated connection. Sometimes the connection may be like this through a intermediate device. The different computers are connected through an intermediate device, and the structure of communication or geographical structure of the network is called the topology. So there are different topologies. If each and every device is connected with each and other device, then we say it is mesh topology. If it is in this type of configuration, there is a central device and all the devices are connected to the central device, then it is called a star topology. Similarly, there may be some network where there is a dedicated link or backbone link through which all the devices are connected. This type of configuration or physical structure is called bus topology. So there are different topologies also. So we have discussed about this in the last class, and we have started another topic, that last class, that is OSI. The full form is
Sir. Hello.
Hello.
Sir. Sir, বলছি স্টার টপোলজিটা কেন
হ্যালো
এর সাথে অনেকগুলো কানেক্ট থাকে?
বলো স্টার টপোলজিটা
ওটা স্যার কেন মাল্টি পয়েন্ট নয় কেন স্যার?
See, when we say that it is multi-point, see, this is a central device. This central device, sometimes called hub, sometimes called switch. Okay, and this is one particular device. How these two devices are connected? These two devices are connected through a single link. It means there is a point-to-point connection between this hub or central device with the computer device. That's why it is called point-to-point configuration. Logic clear? Why it is called point-to-point configuration? But in case of bus topology, this single link, this backbone cable is shared by all the devices. Then it is called multi-point. But here, the connection between hub and a device is point-to-point, dedicated connection. If suppose there is a problem, means suppose this is device A and device A is not able to transmit its data, it's mean there is some problem in this link. How I can identify this link? Because it is point-to-point or dedicated connection. That's why in case of star topology, it is point-to-point communication. Only in the bus topology, it is multi-point. Okay.
Okay, sir.
Now, the last class we are discussing about open system, OSI, open system interconnection or intercommunication, whatever. So, and Remember, this is one, you can say, a layers of softwares, layers of software uh, which which perform the data communication. So this is not a hardware. This is purely software. Layer of softwares means one particular software performing some operation, then another particular software performing another operation. So that's why in layer wise, these softwares are performing its job. Okay. And so sometimes it is called OSI layer. But remember, this is something which is not related to hardware. It means you cannot touch it. It is a software, set of rules, set of programs. In each and every layer, you will see some protocol are active. Okay. Now, so after that, what we have discussed, that whenever I am transmitting one data from a sender device to a receiver device, so I have to follow some rules or protocols. Okay. The first thing, suppose I am the sender and I want to send this information to receiver. Now, since our computer devices are only able to understand binary information, so that's why this particular character set, which is in English language, cannot be transmitted directly. So the first thing that we have to perform, that is, we have to convert it in binary form. How can we convert it into binary form? This is very simple. By using its ASCII value, we can easily convert it into binary form. So this particular step is called translation. So we have to perform the translation from any non-ASCII information or any other non-ASCII code. We have to convert it into ASCII, then into binary form. Okay. Now, in some cases, such as suppose in case of image, which is a huge information, because each and every image pixel is one information, and if it is a color image, each pixel having 3 different values: RGB, red, green, blue. Each RGB having a range from 0 to 255. It means to represent one color information, we require 2 to the power 8 bits. Correct? And similarly, for green, we require 2 to the power 8, and for blue, we require 2 to the power 8. So for one particular or single, for one single, you can say pixel, consisting of that much information in binary bits. And suppose your image is having a size R into C, then you can understand what is the total size of the image. The total size of the image is 3 into why 3 is coming, because it is a color image with RGB into the power 8. That much amount of bits you have to transmit for a particular image. So now if I transmit that amount of data, now what is happening? See, try to understand these things. These are very important. Suppose this is a media communication link through which you will transmit your data. Now remember, this communication link always having some capacity. So consider this is as a water pipe which will transmit water from one side to another side. Now this circumference of the water pipe, or the total volume of the water pipe, will determine how much data it can transmit. Suppose this is the length of the water pipe is L, and suppose this one, this surface area is suppose A. So you can understand the volume of the pipe is A into L. So that much amount of data it can transmit in one particular segment. Clear? So it can transmit at 1 second that much amount of data. Now, so it is called the capacity of the link. This is called capacity of the link. Sometimes this is also having some term which is called MTU. That is the full form of is maximum transfer unit. What does it mean? Maximum transfer unit means the maximum amount of data it can transmit from one particular position to another particular position. That is called the maximum transfer unit. So if this is the capacity of the link, so it means this much amount of data it can transmit in 1 second. So A into L amount of data it can transmit in 1 second. Okay. Now if this is your total size in bits and this is in bits capacity, so you can understand how much time you require. So that much time you require. This is this divided by A into L. That much amount of second you require to transmit this particular image from one particular portion to another particular portion. Now there is another interesting thing. This is called the capacity of the link. There is another thing which is called propagation delay. Another term which is called propagation delay. What do you mean by propagation delay? The meaning of propagation delay. Suppose this is my data. Suppose this is my data. I want to transmit this data from sender to receiver, and this is the link. So how I will transmit the data? First I will send the bit 1, then the next one. So now this one bit, this first bit, when it releases from the sender and when it reaches to the destination, the time required to transfer only first bit or the one bit from sender to receiver is called the propagation delay. Okay. Now this propagation delay is same for each and every bit, because this bit will transmit from there to there. The time required to transmit is if T1. Then for this bit again we need T1. For this bit again we need T1. For this bit again we need T1. So for each and every bit we need T1 time to transmit from one particular device to another particular device. So this into size, or you can say data bits, total capacity of the image or total capacity of the data. That amount of time required to transmit from one device to another device. Okay. So when we are transmitting data from one device to another device, if the size of data is increased and if the maximum transfer unit, the maximum capacity of the link is lower than that, then what we will do, we will transmit the data in some compressed form. So you have to compress the data. Okay, so there comes the compression, data compression. There comes the data compression. So I will compress the data. Again, another important thing, when I am transmitting some information, it may be consisting of my bank password, email ID, user ID. So I am sending those information also. And since after some times it becomes wireless, so data will be traversing from one device to another device in wireless media. So if I am able to capture the particular frequency range of that data, I can easily capture the data. It means my secure information is now vulnerable. Anybody can capture the information. So what is the logic? How can I transmit the data? The first time that is used by Julius Caesar, whenever he is sending some information to its colleagues, he will transmit, at that time it will be transmitted to some carrier. Means suppose some person is carrying some postman is carrying the information. So what he started, Julius Caesar, he started to convert the data in some form. It means this is called the cryptography or cryptic form. So that if in the intermediate transmission time, if anybody captured the data, he could not understand what is written in the letter. So that's why there is one interesting cipher concept which is called Caesar cipher. Okay, so the important thing, the security of my data. So we have to perform another important thing, that is encryption. So you have to perform encryption. And if you remember last class, I have told you that all these things from sender side, obviously from the receiver end, it must be first de-encryption, then decompression, and then you can say retranslation. So we have to convert in reverse order. So all these things are done, these three tasks are done by one particular software, and that particular software having a name, or you can say this particular layer in OSI having some name, and the name of the layer is presentation. So what is the task of the presentation layer? So presentation layer is converting my own data in some presentable form so that I can able to transmit it. So presentation layer is converting my own data in some presentable form by performing the operations like number one, first I have to perform the translation, okay, then I have to perform data compression, okay, and then I have to perform encryption. So after performing all those things, the data will become some presentable form for the next layer, means next part of the software. Okay. Now, what happened in the next part? I have already told
Hello.
you. Bolo.
Sir, translation টা কি?
ট্রান্সলেশন হচ্ছে আমি তো লিখছি একটা ইংলিশ ল্যাঙ্গুয়েজ, এবার ধরো হিন্দিতে লিখছি, কিন্তু আমাকে তো সেটাকে বাইনারি ফর্মে কনভার্ট করে পাঠাতে হবে।
ও,
তাহলে এইটাকে বলছি আমরা ট্রান্সলেশন।
মানে কি মেশিন লেভেলে যখন করছি তো, মেশিন লেভেলে ওইটাকে
এক্স্যাক্টলি, মানে আমার কোনো নন অ্যাসকি কোড থেকে আমি ওটাকে বাইনারিতে কনভার্ট করছি।
আচ্ছা আচ্ছা,
সেটাকে আমরা বলছি ট্রান্সলেশন। Okay, so I've already told you that each and every means media having some maximum transfer unit, maximum capacity to transmit. So suppose my data is this amount, or you can consider one example that I need 10 kgs of say 10 kgs of rice, okay, but I have one bag which can only able to transfer 7 kgs at a time. So I have one bag which can transmit rice up to 7 kg at a time. So if I want to carry 10 kgs of rice, what I will do? I will perform, first I will carry 7, then I will carry the next 3. So how many times I am carrying the information? I am carrying the information 2 times. So similar thing will happen here. Suppose this is my original data that I have to transmit, but my media having a capacity, which is this. So what I will do, I will means my message will be broken into parts. My message will be broken into parts. These are the different parts that I will transmit, and you will very easily able to see this whenever you are sending some message to your friend through SMS. If the message size is huge, then what happened? The first part of the message and then the second part of the message will be transmitted separately. That you have already seen, I hope so. So this is why this is happening, because our link capacity, our protocol capacity having some maximum transfer unit range, and based on that maximum transfer unit, if my data becomes huge, then I have to break it into smaller parts. So that's why we need some layer which will perform this operation, which will break the data into smaller parts, and these smaller parts will be transmitted in as an individual data. Now, I hope you have seen that when you are downloading something to your internet, HTTP, when you are downloading something through HTTPs, what is happening? Your data, remember our internet data is always coming in smaller packets. It is not a continuous stream of data. It is packets. Means first it is sending a packet of size like this, then it is sending a packet size like this. So means if you see the internet speed, it will be vary. In first second it is sending up to this, then it is sending up to this, then it is sending up to this. So it is discrete packets. It is sending the data in packets. That's why whenever you are downloading some image, you will be able to see that first when the image is started downloading, it will be having some blurry image. Why? Because some portion of the image information is just came. Then it will send the second means packet. So in time you will able to see that the blurry image becomes sharper. Means now the total image first. So and you will see that data is downloading in varying speed. So remember this, why this is happening? Because our internet or our link having some maximum capacity. So whenever I am transmitting a huge data, it will be broken into pieces. And this breaking down of image or making the data in smaller parts is done by one particular layer. Not only after breaking the data into smaller parts, what I have to do, I have to transmit all the packets as an individual data. So try to understand this thing also. Suppose there is one sender, there is one receiver, and suppose there is a direct connection and there is a via connection. Okay, there is another via connection. Are you getting? This is our internet, almost like a graph. Na? So from in a graph, to reach from one node to another node, there may be different possible ways. So there is one way like this through which it will transmit. There is one way through this. There is another way through this. So there are three possible ways. So when you are transmitting a data, huge data, and suppose your data is broken into three different parts, your huge data is broken into three different parts. Okay. Now, suppose this is your image. Image is broken into three parts. This is one part. This is another part. This is another part. Okay. Now, this three individual data, packet 1, packet 2, packet 3, will be transmitted in this link. Now, suppose packet 1 is transmitted through this link. Now, since already packet 1 is transmitted through this link, so I will consider that this line or link is busy. So packet 2 may be transmitted through this. And since 1 and 2 already occupied or already in busy mode, so I'll transmit the data 3 through this link. It means the total data 1, 2, 3, which will create a particular image, is transmitted through different links, and ultimately when it reaches to the receiver, it may happen there may be delays. Why delays? Suppose this data 1, when it reaches this particular intermediate device, somehow this device is not at that time active, so it will store the data for a particular time. Then after some time, when it is active, it will transmit. So in this way, although you have transmitted the data in sequence 1, 2, 3, it may happen in receiver end, this data is received in this form, first 2, then 1, and then 3. So it means your data is totally out of order. Why this is happening? Why this data is out of order? Because individual packet is transmitted through different links. Okay, and they reach to the destination in different times. That's why it may happen it is out of order. But I need the image to create the image. I need the data in sequence 1, 2, 3. So that's why when I am breaking the data into smaller parts, I have to give some checkpoints. This is called checkpoints. I have to give some checkpoints. Why these checkpoints are given? Because so that we can easily, when we receive in the receiver end, we can easily make them in sequence by knowing the checkpoints. Okay, logic clear? And I hope you have seen when you will download something from the BitTorrent. Then what happened when you are transmitting after if your link is failed, then when you restart the downloading, you will see it will start downloading up to which point it already downloaded. But in normal downloading, if your downloading is going on and somehow the link is not available, then what will happen when you restart the transmission, it will transmit again from the starting point. So what happened in BitTorrent, it will give some checkpoints, but in sometimes it may not give checkpoints. So in that case, you have to again start your transmission. So this is the meaning of checkpoints. Means checkpoints will give you from to make the out of order data into sequence. So that is the use of checkpoints. Okay, and see throughout this data transmission, the link between sender and receiver must be on. The link between sender and receiver must be on when this data is transmitting. So that will be maintained. Okay, so that connection or must be maintained. বলো
স্যার বলছি আপনি যে টরেন্টটা বললেন এই সেন্ডার আর রিসিভারে এতগুলো লিংক যেটা দেখালেন এইগুলো কি ধরেন টরেন্টেরই লিংক বলছেন অ্যাজ অ্যান এক্সাম্পল মানে ধরেন আমি গেম ডাউনলোড করছি
হ্যাঁ
সেই হিসেবে দেখতে পারবো
টরেন্টেরও হতে পারে অন্য কিছুরও হতে পারে যে কোনো ক্ষেত্রেই এরকম
আইডিএমও হতে পারে
একদম কারণ কি আমি বলছি দেখবে তুমি যখন মেসেজ সেন্ড করো ধরো এসএমএস এ দেখবে ধরো মেসেজটা খুব বড় হয়ে গেল দুটো পার্ট হয়ে গেছে মেসেজটা তুমি দেখবে কখনো সেকেন্ড পার্টটা আগে চলে আসে ওইটা এই কারণেই যেহেতু ডিফারেন্ট লিংক দিয়েও তোমার কাছে ট্রান্সমিট করছে
স্যার আমার একটাই কোশ্চেন আছে যে বলটা কি আমার একটা স্পিড আছে স্পিড লিমিটার আছে ধরে নিন 1 Mbps 2 Mbps এর স্পিড আছে এবার যখন এইগুলো প্যাকেটে হচ্ছে প্যাকেটে ডাউনলোড করছে আমি দেখছি স্পিড গুলো আমার স্পিডটা প্রত্যেকটা প্যাকেটের স্পিডে চলে আসছে ছোট 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 200টা প্যাকেট 300 400 500 প্যাকেট এইটা কিভাবে হচ্ছে এই স্পিডটা সবার জন্য সেম কিভাবে হয়ে যাচ্ছে
না সবার জন্য সেম কেন হবে এটা তো ভ্যারি করবে সবার জন্য
একটু আমি আমার বেলা তো আমি দেখি সবসময় সেমই থাকছে ভ্যারি ততটা করছে না ভ্যারি একটু করে সেটা তো জানি
হ্যাঁ এবার তো উচিত তোমার ফিক্সড আছে মানে তোমার যে আইএসপি যে সার্ভিস প্রোভাইডার তার ব্যান্ডউইথ ক্যাপাসিটিটা হয়তো খুব বেটার সেজন্য তোমাকে ঠিকমতো পারফরমেন্স দিতে পারছে মানে ব্যান্ডউইথ মানে হচ্ছে এইটা এই যে পাইপের যে ভলিউম এটাকে বলা হয় ব্যান্ডউইথ
আচ্ছা হ্যাঁ
এইটা যদি ঠিকঠাক থাকে তাহলে তুমি স্পিডটা সবসময় ঠিক পাবে মানে অ্যাকচুয়ালি কি করে সার্ভিস প্রোভাইডাররা কি করে ধরো 100 MB এর একটা ব্যান্ডউইথ কিনেছে ঠিক আছে এবার ওর কাছে হয়তো 50 জন লাইন নিয়েছে তাহলে এই সবাই বললো আমার 2 করে লাইন লাগবে এবার ওর কাছে 100 আছে 50 জনকে দিয়েছে 2 করে ওর টোটাল ক্যাপাসিটি কভার হয়ে গেল এবার ধরো ও কিন্তু 50 জনকে দেয় না ও কিন্তু 60-70 জনকে দিয়ে দেয় কারণ এটা আমরা ধরে নিচ্ছি যে সাইমালটেনিয়াসলি সবাই হয়তো অ্যাক্টিভ থাকবে না এটা প্রবাবিলিটিতে দেখা গেছে যে সবাই একসাথে অ্যাক্টিভ থাকে না ঠিক আছে সেই জন্য কি হয় ওটা কিন্তু মেকআপ হয়ে যায় এবার যখনই এটাও করছে তখনই কিন্তু আবার স্পিড ভ্যারি হতে শুরু করে ঠিক আছে আর ইন্টারনেট তো তোমার আর তোমার সেন্ডার আর রিসিভারের মধ্যে তো একটা লিংক দিয়ে নেই ডেডিকেটেড লিংক নেই মানে আমি বলতে চাইছি একটা পাইপ দিয়ে তোমাকে যদি আমি জল পাঠাই সেই জলটা সবসময় কন্টিনিউয়াস সেম ফ্লো হবে কিন্তু আমি যদি তোমাকে বিভিন্ন রুট দিয়ে লাইন করে করে পাঠাই যেটা আমাদের ঘরে জলের পাইপে যে লাইন আসে মিউনিসিপ্যালিটির লাইন তার স্পিড কি সবসময় এক থাকে বাড়ে কম কারণ ধরো কেউ ইন্টারমিডিয়েট কেউ হয়তো কল খুললো তখন সেখান দিয়ে জল বেরোলে তুমি ঘরেও দেখবে তোমার পাইপ লাইনে তুমি একটা কলে যদি কাজ করছো আরেকটা ঘরে কেউ কল খুললে স্পিডটা কমে যায় সেম জিনিস এখানেও হবে ইন্টারনেটও যখন অনেকে অ্যাক্টিভ হয়ে যাবে তখন কখনো স্পিড বাড়বে কখনো কমবে এটা ভ্যারি করবে তোমার ঠিক আছে
বুঝলি
আচ্ছা so to perform all these things means the break your data into smaller parts then give checkpoints then control the dialogue between sender and receiver throughout the communication we need another layer and that layer is called session layer. It will control the session. It will control the session between sender and receiver. So what are the tasks it will perform? It will perform number one, it will break the data into smaller parts. Then it will give some checkpoints to understand or to make the data sequence in the receiver end, and then it will perform as a dialogue controller between sender and receiver throughout the communication. So we need these things. See, after your data is in encrypted form, when it is in presentable form, you will perform the next step. You will, according to your maximum transfer unit, you will break down your data into smaller parts. Then you will give some numbering or checkpoints. Then throughout the communication, since you are transmitting your data into smaller parts, you have to maintain the dialogue between sender and receiver. To perform these things, we need another layer that is called session layer. So far we have discussed presentation layer, then session layer. And then comes the most three important thing whenever we are transmitting data. Now let us consider our mail transmission. How we will transmit our mail? Now, see, whenever I am sending a mail, in the envelope, I will write to Mr. say Roy, then some say house number 2FF, 2PP. Okay, then finally I will write the PIN number. So these three things are very important. Whenever I am sending some letter, I will transmit, or I must mention these three information. Information 1, information 2, information 3. The PIN number, that is also very important. So what does it mean? Now PIN number mention some particular locality. So this is representing the PIN number 700101. Okay. Then house number, a particular house in this locality, that is the house number 2PP. And then inside the house there is one person, that is Mr. Roy. Now see, very interesting that if I write in my letter Mr. Roy in this particular house, each and every male person or male member is Mr. Roy. So how can I identify who is this Mr. Roy? So I have to mention, remember, I have to mention along with this Mr. Roy, I have to mention the particular name. So I have to mention Hiranmoy Roy. Okay, logic clear? So this three particular type of information is very important whenever I am transmitting a data from one device to another device. Why? See, this PIN number resembles to a network. First I have to reach a particular network. Then in this network, I have to reach a particular device, the house number. Logic clear? Then in this device, there are different software running. There are running FTP. There are running HTTP. In which port I have to connect? There are different software which is resemble to the different person belonging to a particular house. So there are different software running. So I have to send the data to a particular software. So I need these three particular addresses when I am sending my mail. Similarly, when I am trying to communicate between two devices, I have to transmit it in this form. So suppose this is one network where there are different devices. These are the devices which consist a particular network, network 1. There is another network which is having different devices. This is network 2, and suppose this is device 1, and this is suppose X1. This device trying to send a data to this device. D1 trying to send a data to X1. Then first what D1 will do, D1 will send the data through this communication link. It will reach first the network, then it will search the particular device, then it will search the particular software which is running. So we need three different addresses. The address of the software is called port address. Each and every software will run in a particular port or address, that is called port address. Then the device address, or sometimes it is called machine address or physical address of the device. So we need the physical address. Okay, then we need another address to recognize the particular network. There are different networks connected. Which network? So this is network 3. Which network I have to transmit the data from N1? So I need the network address 2. So this is network address, or sometimes called logical address. So all these addresses are very important when I am transmitting my data from one device to another device. This physical address, also called MAC address. I hope you have heard these terms, MAC address. So all these three information or three data is very important whenever I am transmitting one data from one device to another device. To recognize first the network, then the particular device, and then the particular software. So the first layer which will provide us the port address is called transport layer. Transport layer. The main purpose of this layer is it will provide the port address. Okay, then the next layer is called network layer, which will provide us the most important network address or logical address. And then finally the data link layer, which will provide us the address which is called MAC address or physical address. And so if we see the layer by layer, the first layer is presentation, okay, then comes the session, then comes the transport. They are in sequence. It must be in sequence, not random order. Then data link. Okay, these 5 layers are very important, and above this 5 layer there is one layer which will provide us the user interface, the main information that you are able to see, and whenever you are pressing the send button, it will transmit it through physical layer. So we are only able to see the layer which is called application layer, which will provide us the user interface, UI or GUI, you can say, graphical